Hi guys, this is O-Level Chemistry, paper 11, November 2020, question 1. A student needs to measure 17.60 centimeter cube of hydrochloric acid. The student has access to apparatus commonly found in a school lab. Which piece of equipment should be used to measure 17.60 cm cube of hydrochloric acid? Now, the volume that they have given us actually clearly tells us what we need to use to measure this volume. Since the accuracy is up to two decimal places here, the only piece of apparatus that can measure accurately a variable volume, because 17.60 is variable, it's not fixed. Pipettes are used to measure fixed volumes accurately. Burettes are used to measure variable volumes accurately. So accuracy is the need here, and it is a volume that is in decimals. So we would use a burette. So the options given to us are burette. Yes, this is correct. A gas syringe. A gas syringe also measures accurately, but volumes of gases, variable volumes of gases. A measuring cylinder. A measuring cylinder is not an accurate measurement piece of apparatus. A measuring cylinder can only be used to measure approximate volumes. Like in the case if we have some solution in excess and we are supposed to take 25 cm cube of it. So we will use a measuring cylinder because its accuracy is not as good as that of a burette or a pipette. But if we need to measure 25 cm cube of a solution with accuracy, then we would use a pipette. But pipette cannot be used to measure 17.6 cm cube of the acid. It has a fixed volume, only that volume can be measured using the pipette. So neither measuring cylinder nor pipette is the correct answer here. So the correct option for this question is option A. Question 2. When calcium carbonate is added to dilute hydrochloric acid, carbon dioxide gas is released. Three sets of apparatus are shown. Which set of apparatus are suitable together with a stopwatch for following the rate of reaction? Okay. So apparatus in one can be used to measure the time it takes for the mass to decrease, because we are measuring the mass. So we are going to measure the mass of CO2 loss. So experimental setup 1 can be used. In experimental setup 2, we have collection of gas. So we can measure the time it takes to collect a certain volume of gas. So experimental setup 2 is also useful or suitable. In 3, we have collection of gas, but the gas produced here is going to be CO2, which is soluble in water. So when collected over water, some of the CO2 will dissolve. So when it dissolves, we will not be able to measure the volume of CO2 produced accurately. So we will not be using this apparatus setup for our experimentation. So 1 and 2 are correct, making option B the correct option for this question. Question 3. Some substances may be separated using paper chromatography. The diagram shows the results of running two mixtures in a suitable solvent. Which spot has an RF value of 0.37? So we would need a scale here. We would need to measure the distance traveled by the solvent. This is known as the solvent front. And for each spot A, B, C, and D, we would measure the distance moved by the spot. So this would be known as the solute front. So what we will do, we will calculate the RF value by using the formula solute front divided by the solvent front. Now, one thing, the more closer the solute front is to the solvent front, the bigger would be the value calculated, yeah, meaning the RF value. And the further away it is, the smaller would be the RF value. The RF value we require is around 0.37. That means it needs to have traveled approximately 37% of the paper or 40%. So we can actually guess that the correct answer here would be option B. But when we calculate the values by measuring the distance traveled of solute upon solvent, we obtain the correct answer as option B. Question 4. Petroleum crude oil is separated into useful fractions by fractional distillation. The positions at which the fractions X and Y are collected from the fractionating column are shown. Okay, X is collected above and Y below. That means the boiling point of X is low, the boiling point of Y is high. And also the MR of X would be low and the MR of Y would be high. These are the bases on which the fractionating column has been set up. So this is the information we can actually predict by looking at the positions of X and Y. So now the question asks, which statement is correct? The temperature increases up the column? No. The temperature decreases up the column. So this statement is incorrect. X condenses at a lower temperature than Y. X is above Y, so X will condense at a lower temperature. Yes, this is correct. Next, X has a higher boiling point than Y. We have already figured that the boiling point of X would be lower. X has a longer chain molecule than Y. Since the MR of X is less, that means its chain length would also be less. It cannot be longer. So this makes option B the correct option for this question. Question 5. Compound. Question 5. Compound X is a crystalline solid at room temperature and pressure. An aqueous solution of X is tested as shown. Okay, it's a crystalline solid and its aqueous solution is tested. Okay, acidify with dilute nitric acid and then add aqueous barium nitrate. No visible change. So, absence of sulfate ions. Add aqueous ammonia, white precipitate soluble in excess. The only ion that gives a soluble white precipitate with excess of aqueous ammonia is zinc, Zn2 positive. So what could be the identity of X? Ammonium carbonate. We have not tested for either of the ions. Sodium sulfate, we tested for sulfate, it was absent. Calcium nitrate. Uh, we did not. Oh, yes. The ammonia test. Calcium would give a white precipitate, which would be insoluble. So calcium is absent. And zinc chloride. So we tested for zinc. Zinc is present. Since this is the only salt containing zinc ions, we did not test for chloride ions. So our correct answer for this question is option D. Question 6. When aqueous sodium hydroxide is added to a solution, a white precipitate forms which dissolves when excess sodium hydroxide is added. Okay, a white PPT which dissolves on excess addition of sodium hydroxide. We could have Al3 positive ions or we could have Zn2 positive ions. These two will be forming white precipitate with sodium hydroxide which would dissolve on addition of excess of the solution. Which ion could be present in the solution? Aluminum ions, yes. Calcium, calcium would give a white precipitate which would be insoluble. Copper would give a blue precipitate which would be insoluble, and sodium does not give a precipitate. So the correct option for this question is option A. Question 7. Why does a balloon full of helium gas become smaller as the temperature changes from 30 to 10? The gas contracts. The gas, okay, now let's look at the options. The gas condenses to a liquid and so takes up less space. There is no indication of change of state, so we cannot say it is condensed to a liquid. The gas particles become smaller at lower temperatures. The size of the particles do not change with change in temperature. The gas particles diffuse through the balloon and escape. Uh, it is inside a rubber balloon. This is not possible by a slight change of temperature of 20 degrees. And anyway, the air is trapped inside the rubber. It will take a long time for particles of gas to diffuse out. So the last one, the gas particles move more slowly, so reducing the pressure. Yes. When the temperature decreases, the kinetic energy that the gas molecules possess decreases. Thereby, they move slowly instead of moving faster, which was possible at 30 degrees Celsius. So when they move slowly, they collide with the walls of the containers less frequently, and lesser collisions with the walls of the container, in this case the balloon, would mean that the pressure would decrease. So option D is the correct option for this question. Question 8. The diagram of an ion is shown. Okay, so this is a positive ion which has 2, 4, 6, 8, and 10 electrons remaining, and it has lost 1 electron. So 11 electrons. So looking at the periodic table, this particular diagram represents Na positive ion because the proton number of sodium is 11, and this particular ion had 11 electrons before one was lost. Okay, what can be deduced about the number of protons in this ion? Number of protons would be its proton number. Proton number would be 11. So it has 9 protons, it has 10 protons, it has 11 protons. You cannot deduce the number of protons from this diagram. Of course you can. You just calculate the number of electrons plus the electron that has been lost. So in total 11. Option C is the correct option for this question. Question 9. The circuit diagram shows an experiment using a rod of copper and a rod of graphite. Okay. When the switch is closed, the bulb lights because an electric current flows through the copper and graphite. Which particles move through these two solids? Particles that move. Okay. Copper ions. No, ions will not move. So A and C are incorrect. B and D are the correct options that we will continue with moving onwards. Electrons flow. Yes, electrons flow through the metals when electricity is conducted. And carbon ions, again, only flow of electron is possible, not flow of ions. So this makes option B the correct option for this question. Question 10. Which material has the highest melting point? Ammonia. Okay, now since they have listed the substances here, we are going to find out the type of bonding that they have, and based on that, we will figure out the melting point. So ammonia is a simple covalent molecule. Next is methane is also a simple covalent molecule. Sodium chloride is an ionic lattice, and water is a simple covalent molecule. Since ionic compounds have a greater melting point than covalent compounds, option C is the correct option for this question.